Hey, what's going on everybody? It's your bro, hope you're doing well. In this video, I'm going to explain queues in computer science. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Whoa, hey, we're talking about queues today. So queues are a Fifo data structure, not to be confused with FIFA. Fifo as in first in, first out. An example would be a line of people. It's first come, first serve. Whoever's there first gets helped first. So this is a collection designed for holding elements prior to processing. It's a linear data structure. Here's an example. Imagine that we're a cashier and we're selling tickets to a concert. We will help whoever approaches our register first. It's first come, first serve. In other words, it's FIFO. First in, first out. Unfortunately, a wild Karen appears and she would like to talk to the manager. Now, Karen is going to waste everybody's time, so it's going to be a while. In the meantime, Chad enters the line. He will enter in at the back and wait his turn, followed by Steve, and then Harold. So Karen is at the head of our queue, our line, and Harold is all the way at the back, our tail. As you can see, Harold is very anxious right now. Once Karen has been defeated, Chad will move to the head of our queue. So Chad will now be helped next, and Harold will still be at the tail until somebody else enters the line. Once Chad has been helped, he will move out of our queue, and Steve is at the head now, and the tail will move as well. And then once Steve has been helped, Harold is the only one currently waiting in line for his tickets. He will be at both the head and the tail of our queue. So that's kind of how a queue works. It's first come, first serve, FIFO, first in, first out. If you were here first, then you will be helped first. Now, the concepts of adding and removing objects from a queue are known as both enqueuing and dequeuing. Enqueuing is the concept of adding an object to the end of our queue, our tail, and dequeuing is when we remove an object from the head of our queue. Now, what methods do you need to enqueue and dequeue from a queue? Well, it really depends on the programming language that you're working with. A lot of you voted for data structures and algorithms using Java, so I'll probably stick with Java then. Here's an example. Now, to enqueue and dequeue, we need, well, a queue. So let's create one. Queue. Then we need to list the data type of the objects that we're going to add to this queue. Let's work with strings because strings are objects and they're fairly simple. And I will name this queue queue equals new. Now check this out. I will attempt to create a queue object and instantiate it. And the data type is string, and I will add a constructor. Now, we cannot instantiate the type queue. Here's the reason why. So if we take a look at the queue class right here, queue is actually an interface and not a class. And based on our lesson on interfaces, we cannot create an instance of an interface. An interface is meant to be more of like a template that we can apply to another class. So to utilize queue technology, we need a class that implements queue. Now, taking a look at our Java collections hierarchy, there are two classes that implement queues, one of which is the LinkedList, and the other is the PriorityQueue. Now, PriorityQueues, they will rearrange their elements based on a certain priority, so they wouldn't be a good example. So to utilize the features of a queue, we are going to create a linked list because we cannot instantiate a queue itself because it's an interface. With that being said, let's change equals new queue to equals new linked list. We won't be focusing on any of the features of linked lists. We'll save that for another video, maybe the next one. I haven't decided yet. So we will only cover the features that linked lists will utilize via the queue interface. Now, with the queue interface, there are three methods that we inherit from the collections parent class: add, remove, and element. These will do approximately the same thing as enqueuing, dequeuing, and peeking at the topmost element. However, they throw exceptions, and according to the documentation, it's actually better to use this column of methods instead. These will return a special value. We have offer, which will enqueue or add an element to the tail of our queue. Poll will dequeue. It will remove the head of our current queue. And then there is also peek. It will not remove the head, but it will examine it and return it. So those are the three dedicated methods that we implement via the queue interface. There's some additional methods too, which we'll cover later, which we inherit from the collections class. So let's begin by offering a bunch of people to our queue. This is how we enqueue or add elements to our queue. So first in our line, we have Karen. So to add her to the queue, we would type the name of our queue, queue dot offer. And we will offer Karen to the front of our queue, and she would like to complain to the manager. Next, we have Chad. Queue.offer Chad. Then we have Steve. And lastly, Harold. Okay, now if we were to display our queue, we'll place it within a printline statement. We will pass in queue as an argument, and this should display our queue in order. First, we have Karen at the head, then Chad, Steve, then Harold at the tail. One method that we implement from the queue interface is the peek method. We can use the peek method to examine and take a look at the object at the head of our queue. We're not actually going to remove the object at the head of the queue, but take a look at it. So within a printline statement, I will use queue.peek method. And after peeking over our cash register, unfortunately, Karen is at the front of the line. Now to dequeue, we can use the pull method. So type queue.pull, and this will dequeue your queue. So Karen is no longer at the head of our queue. So let's pull a couple more times for practice. So after pulling twice, Karen and Chad are now gone. Using pull a third time, we'll remove Steve. And lastly, Harold. Now, the nice thing about the pull method is that it will not cause an exception. According to the Java documentation, you can use element to peek, but it will throw an exception. So if I was to use element at the end, this would cause an exception then. So usually it's preferable to use this column of methods, even though they're similar. These will not throw exceptions: offer, pull, and peek. Now with queues, there are some additional methods that you might be interested in. The queue class will extend the collection class, so the queue class inherits everything that the collection class has. And there's some pretty useful methods within here. I'll show you a few. So the first is that we can check to see if our queue is empty. So within a printline statement, I will type queue.isEmpty. And if our queue is empty, this will return true. So if I move this line of code after we offer a bunch of strings, a bunch of people to our queue, if we check to see if our queue is empty, that will be false. There are people currently within our line. So that is the isEmpty method. We can also check to see the size of our queue. How long is our line? System.out.println queue.size. And the size of our line, our queue, is 4 objects. We have 4 people waiting in line to be helped. So that is the size method. And another is the contains method. We can check to see if our queue has a certain object that we're looking for. So within a println statement, I will type queue.contains and then pass in an object. Let's check to see if Harold is at the back of the line. He's been waiting here patiently. Queue.contains Harold. And according to the contains method, Harold is in fact within our line. That is true. However, this method does not give the index the position in which Harold is in. Imagine that we yell out, "Hey, Harold, are you there?" And he yells back, "Yeah," or "True." That's kind of how the contains method works. So these are 3 useful methods that queues inherit from the collection class. Now, where could queues be useful? They're actually used in quite a number of things, but here's a few examples that came to mind. So 1, they can be used in keyboard buffers. Have you ever typed so fast that the computer couldn't render all of the characters onto the screen? And all of those characters were added to a buffer. They were all displayed in sequence, and they were waiting for their turn to be displayed. So with a keyboard buffer, letters should appear on the screen in the order that they're pressed, right? First in, first out. They're also used in printer queues. Print jobs should be completed in order. So we would start with page 1, then page 2, and just follow that pattern. And as we discussed before, they're used in linked lists, priority queues, as well as breadth first search algorithms. Well, everybody, in conclusion, a queue is a Fifo data structure. First in, first out. It's a collection designed for holding elements prior to some sort of processing. It's a linear data structure. Imagine a bunch of people waiting in line. To enqueue, that means to add an element to the tail of our queue to the end. We can use the offer method in Java. To dequeue, we would use the pull method in Java. that will remove the element at the head of our queue. So that is the queue data structure. In the comments down below, let me know what you would tell Karen if she asked to speak with your manager. And that, ladies and gentlemen, is the queue data structure in the field of computer science.